So good morning. This talk is native code pipelines. IoT joins the DevOps revolution. Hopefully you'll find it interesting. My name is Mark Galpin. I am a solution architect at JFrog. This means basically that in addition to getting to go to places like this and talk to you all at community events, I also spend a lot of time working with our customers on DevOps transformations and how the JFrog product line interacts with that. And we'll talk a little bit about JFrog's products as we go through this. Before that, I was an Army contractor for many years, so I always find it a little bit surreal some days when I stand up and talk about DevOps and just think of myself, 4 years ago, I feel like I was decades in the past. Which is a somewhat relevant thought when it comes to today, because part of the problems that we see today when we work with native code, and if you want to do IoT, typically you're talking a certain amount of embedded devices, and most embedded code is still written in C, C++, or as my father, I'm a second-generation software engineer, as my father says, a real programming language. If you're writing in C, C++, you're probably writing some of the coolest stuff out there. Self-driving cars, cell phone OSs, pretty much no matter what you're doing, right? At some level, if you're talking to the hardware, most of the time you're doing that today in C, C++. And some of the most exciting things happening in tech this decade are happening on the hardware side. And in this idea of integrating the hardware into the world. So you're working on cool stuff. I once made the mistake of describing a C program as legacy, and the guy pointed out, this is some of the most advanced technology that anybody has ever written. So it may be an old language, but it's certainly not old stuff. That said, when it goes to working in your tool environment, especially if you have experience in working with other languages, you often feel like your build process is a bit like this. And Frogger is an awesome game. It works. I know plenty of people who still play it today. It's available on my Fire Stick for my TV. I know lots of people who still play it today, really enjoy it, but that doesn't change the fact that it's from the 80s. And sure, it's a great game. It works. You can still have a lot of fun playing it, but there are newer technologies out there that have great capabilities that you might want to leverage. So the question is, how do you modernize the tool chain? And of course, part of the answer to that is our good friend Jenkins. Already today, lots of people are building C, C++ pipelines on Jenkins and doing builds. But the complaint I tend to hear when I speak to people who are doing this is that those builds take a very long time. And the reason those builds take a very long time is that pretty much every time you build, you recompile everything. And while yes, there are approaches you can do to minimize some of that, it gets increasingly difficult to track what you're doing, and for CI builds in particular, where you tend to want a clean environment, people often wipe out all the caches, and you're rebuilding everything. And so About a year ago now, JFrog acquired an open source company called Conan that does package management for C++. And I think this is really going to accelerate things. So we're sponsoring, it's remaining an open source project. We're sponsoring the development of that project. And I'm really excited to talk about it because I really think it's going to transform how C++ development works. It's not that you couldn't do everything before, but it was much harder. So what's the nice thing about package management? So first of all, you build it once, you use it many times. And I should add to that, it comes typically with a versioning mechanism, right? Your average C binary, when you go out on disk, it's mylib.dylib when I went out and searched for lib files out there. Your average Maven jar is going to be mylib-1.0.0.jar. And this is a non-subtle distinction when it comes to figuring out what actually happened during your build and what you're actually using, and really starting to take monoliths and truly break them up into subcomponents where the teams are truly independent and able to be independent. Version numbering is a really annoying and pedantic topic. And if you've been in this industry long enough, you have almost certainly gotten into fights with somebody over how to version number something. But at the end of the day, the reason we have version numbers is so that we can talk to each other about binaries and about the state of the libraries. And if you can't do that, it's very hard to collaborate and leave teams truly independent. The other big advantage of package management is that you can stop storing binaries in source control. Hopefully you're not doing this today, but it's very likely that if you're not doing it today, you were very recently. And the reality is, as much as, while it has been a bad practice to store binaries and lib files, compiled binaries in source control for as long as I can remember, I also have to say that for as long as I can remember, people did it because it was convenient. Package management is an alternative to that, and this becomes a more pressing need if you want to use Git. Storing binaries in a Git repository becomes a much more difficult thing than it was when you were storing it in CVS, Subversion, Perforce, any of those. So package management is hardly a new concept. The Java community has been doing it for about a decade now. Of course, RPMs and Debians have existed for 2 or 3, depending on how you count it. But when we move into working with package management for C++, it becomes a little bit more challenging because the projects tend to be a little bit bigger, a little bit more intertwined. So you tend to need some sort of transit dependency management. But you also have to worry about binary compatibility. One of the great things about package management for Java and about reuse of packages for Java is that I can compile it once and use it anywhere. Whereas with C++, if I want to use it on Windows or on Linux or on Linux with an ARM, these all have to be compiled separately and managed, especially if I want to retain binary compatibility at the linking level for libraries, which, if I'm talking about splitting up large projects, is a critical aspect of this procedure. So when the Conan guys made their project, they had some basic requirements that they had. Had to be able to run anywhere. They wanted it to be completely open source, because in reality, if you're talking about a package manager, you're talking about really, really deep infrastructure. You want to see some of that If you're going to change your source code, you want to make sure that you've got open source stuff. Has to be able to be decentralized, has to be able to handle binaries, but it also has to be able to build from source. Because if you want to do a generalized package manager for C++, it is inevitable that somebody somewhere is going to want to build your package in an environment that you didn't think of. It's going to have to be tracking that binary compatibility issues. So Conan is based on Python, which tends to be a fairly popular language for scripting in C++ build environments, and has the advantage that there's pretty much a Python for every pretty much environment that you want to imagine. And it will work with cross-building. Now, the other big thing that we want to start bringing in, and it's going to take longer, but we recently introduced the concept, is the other great advantage you have when you're working in Java is that you have Maven Central and JCenter. These nice, big central repositories with precompiled binaries for pretty much all of your favorite libraries. Since we host JCenter, and we know how much the community has come to value that capability, we figured that we should also go out and host Conan Center so that people can start sharing precompiled C++ binaries, which you don't have to worry about, did I get all the compiler switches right to build an optimized release build, all that nice stuff. And it's there, it's on the web, it's going to be fast downloads globally because that's what we do. If you are the owner of an open source C++ project and you'd like to be on Conan Center, we would love to have you. And we encourage you to check out Conan Center and check out the procedures for going out there. There's some explanations out on conan.io on how to get your project out on Conan Center. And then you can make free downloads available to the world of precompiled binaries. So that's Conan Center. That's a bit about Conan. Since this is Jenkins world, I know you guys actually care about code. So I'm going to do a real demo. Caveat, this is a live demo. The usual live demo rules apply no matter how many times I scrub my environment ahead of time. There's always the chance that something will go wrong, but I think it'll be fun. And this is a pretty simple demo. I'm not trying to get into everything you can do with Conan here. I just want to show you a little bit of the simplest use case for Conan. And it is very flexible and able to do a lot of things. But in the simplest use case, I have a single file, fairly simple C program that is depending on, thank you, the joys of PowerPoint. Really simple file that uses POCO to go out and calculate MD5 sums, and also has the ability to do some regexes with Boost. Pretty popular libraries for security and for general utility functions in C++. Wanted to include them in. And so in addition to my demo CPP file, you can ignore commands.list. That's just in case I forget what I need to type. I have it there. This Git repo is out on GitHub. You can look at it, see everything I did. But I have a Conan file that just says I depend on POCO and Boost, and that I want to generate a CMake environment for this code. And then I have the beginnings of a CMake list file that give me the beginnings of the instructions for the CMake. And if I go out to do an install on this, it's going to fail because Boost and Poco aren't there. So first thing I want to do here, since I've already declared the dependencies in my Conan file, I'm going to do a Conan install. I'm sorry about that. Let's clean it up. Conan install again. There we go. So it's going out to Conan Center, grabbing a whole bunch of binaries to run things, resolving a version conflict between two versions of zlib, deciding to go with the latest version of zlib. And then it comes down here and it says, sorry, I don't have a copy of bzip2 for the Apple compiler available. And this is a little bit disappointing, but I can do exactly what it suggests and tell it, go out and build it yourself. So bzip2 isn't one of the primarily declared dependencies. It's actually a dependency of OpenSSL. OpenSSL in certain environments requires bzip in order to work. Can I make it bigger? OK. Make it a little bit bigger. So I'm going to run the same command again. And it's going to go out and download the source package for bzip2 and build it for my Apple compiler. And then it says it wants to build Boost. So building Boost is not a live demo activity. It takes about 10 minutes to do on my laptop, and this is not a wimpy laptop. So instead, I want to grab Boost from somewhere else. And so what I'm going to do is I am going to add an Artifactory server. How many of you are familiar with Artifactory, out of curiosity? That's what I like to see. Makes life simple, so I'll skip the basic explanations. So I'm going to add an Artifactory server with a Conan repository. And in fact, this command, if I go out to my Artifactory server, be a little bit smaller than that. And I go to Conan local, and I hit set me up. I log in first. And it gives me this exact command right here in the set me up. Tells me how to set up my credentials, and gives me commands also if I want to upload things. So I'm going to do this. I'm going to add -insert because I want this to be my primary Conan registry. So it's going to put it on top. And since I went to all the effort of building bzip2, I'll upload that to my Artifactory server. I have lost the mouse. There it is. And it's going to give me the version that it built of bzip2. It's going to upload the whole thing. Oh, right. I forgot a flag. Oops, sorry. No, it was the wrong repository. There we go. I forgot to specify it. There we go. Now it's uploading it correctly. And now I'm going to blow away my cache. And we're going to do a Conan install again. And it's going to go and grab everything. And this takes about 30, 45 seconds, maybe a little bit longer this time because the internet connection isn't that great. It would be much faster, of course, if my Artifactory was actually on my local machine rather than out in the cloud. But still, I've actually timed how long it takes to build the whole thing from source. It took 12 minutes. That did not take 12 minutes. And this is, the big point. So that's kind of the basics of Conan from the command line. But we are not in the command line business here at Jenkins World. This is not a good answer. So what does it actually look like? And since most of you are already familiar with Artifactory, I'll go through this process a little bit quickly. But the basic process I'm trying to achieve here is what I've done so far. Developer working on code on their own machine, committing it to source control. And then Jenkins goes out and builds it so that it's a reliable, reproducible build. And just like I just did here, it's going to go out, resolve it from Artifactory. And it will also deploy the results of the build back to Artifactory with a bill of materials that says, this is where this build came from, this is how it was created, this is what it's all about. And after you've done that, then you probably want to mature the build in some way and test it, maybe do some security investigations, whatever it requires to take a build from a release candidate to a release, which is usually a multi-step process. I'm just kind of hand-waving it away here. And then maybe I am going to be putting it out, deploying it on my production infrastructure. But I said that I would talk about devices. So if I want to put it out to devices, I have to get to those devices. And so I actually have to distribute those binaries to arbitrary locations around the globe. And we have a product called JFrog BinTray. And we've already used BinTray once in this because that's what's hosting Conan Center. And while Conan Center itself is very, very small, BinTray as a whole with JCenter and Homebrew as being things it hosts, plus other private binaries, hosts about 2 billion downloads a month. So it scales quite nicely on the CDN. And this gives you a point of external consumers. How do I get to it? And with C++, as I said, the process isn't really different. Today, you probably have a Jenkins server that runs any one of these things and creates an application out of them. But what we want is to make that process faster. And because the reality is, it's not really continuous integration if it takes 8 hours to build. Nightly builds are great, and they're a great first step. I encourage everybody to do them if you haven't gotten there. But if it's going to take you all day to run your builds, then you're not giving that feedback to your developers on how things are improving and how the test process is going that you get out of a continuous integration environment. And you're certainly not going to be able to, turn around a release in a matter of hours if you discover that you just went and pushed a really bad update to a whole bunch of devices and you need to fix that right away. If it takes you 8 hours to build, you have a big problem on your hands. So to kind of extend the standard analogy, I now have the ability with Conan, I can retrieve the libraries from Artifactory. And it's not just a matter of being able to retrieve what I request for. That's not that hard to do in Artifactory. We have a command line interface that you can build a file spec for to do that. You could do that in the old days off an NFS share. What's now special is that, as we saw in my little example, I just said I needed Poco and Boost. It knew that in order to build Boost, it needed bzip2. Actually, sorry, I got them wrong. In order to build Poco, it needed OpenSSL. In order to build OpenSSL, it needed bzip2. So it went out and got everything I needed to ensure it builds. And this is critical, again, in being able to separate out teams. The example I'm giving here is one strictly open source public libraries. Pretty simple. But if some of those libraries are in-house, if an individual development team can't change what they require in order to build without going back to all the other projects and saying you have to change your build environment, then you don't really have an independent team that's able to work on their little piece of the code without worrying. It's more than just an API contract that they now have to honor. So we're going to go out, build our library with its dependencies. And now you can push that library back into Artifactory and have a grand circuit as you go up the stack of binaries that need to be built up to your full application. So let's talk about Jenkins pipelines. So I was going to switch this over to a declarative pipeline last night. The Artifactory DSL doesn't support declarative pipelines yet, but declarative pipelines are really cool in the sense that you can put in a little section called script, and you can put in anything from the Groovy DSL into your declarative pipeline. It's really awesome. So we're gonna look at one that stays pure Groovy DSL version, because when I went to convert it, I discovered something else, a larger bug that I had to address in the process, and it didn't manage to get to taking care of doing the conversion over. So. But Groovy Pipeline DSL is also very cool and indeed more powerful and more flexible. So what all are we doing? Fairly simple stuff. So we have the Jenkins Artifactory plugin installed. We identify a server that we want to use from Artifactory, and we create ourselves a Conan client and a build info object. Then we go out and we get our Git repository. We also collect the environment variables on the slave. Then I go into the specific directory that I'm building, and I get rid of the internal dependencies out to the web, because I've actually uploaded all of the requirements to my Conan X local repository and Artifactory, so I don't have to have anything from bin tray in my build environment. And so I add the two remotes, Conan local, Conan X local. And then I just run and install. And at the end of it, I do an upload of everything out to the external local. If I did have to build something because I went and I added a new compiler environment, it's going to download the sources and build them, and then it's going to upload them up to the repository so that they continue to be built again. And then I have to run my actual build, which in addition, after I've done the Conan install, which I didn't actually do in my previous demo, I actually have to run make. And so I'm cleaning up everything in here just to make sure nothing is cached. And then I'm running the first run of CMake to build out the CMake environment. And then I do a CMake build. I append the version number to my executable just so we can track it easily inside Artifactory. And I upload it to Artifactory. And then I confirm that the binary actually works. And I promote the binary. Usually the testing is more extensive to do a promotion, but try to keep it simple. And then I distribute it. And I'll talk a little bit more about the distribution in just a moment. Pretty basic stuff. We'll go out here and kick it off. And for the most part, you've already seen what you're about to see here because it's looking very much like it looked when I did it on my laptop. So while that's running, we can go in and look at the build information that this provides. It's pretty basic. I don't have, say, the in-depth knowledge that I can get out of something like Maven where I can say specifically each dependency came from a certain purpose yet. But I do have a list of all of the Conan packages that got downloaded in the course of my build. Various TGZ files and this gives me the idea of which version of each did I get. So I was downloading bzip 106, boost 160, Poco 17. I can see all of those things. And I have the binary I created, app29exe. I have my environment variables. I can diff two builds against each other. And I can see that while my exe has changed, basically nothing else has. Which means that probably if build 29 is broken and build 24 was not, one is willing to hypothesize pretty strongly that somebody screwed up the source code, not the build environment. Always a useful thing to be able to clarify. And I have the build info JSON, which contains all of this information in a JSON object that I can parse later, do things with if I want to go back and reproduce the build. This is what it takes for true build reproducibility. You have to know exactly what binaries you pulled. You have to know exactly what your environment variables were. And if you have that information, you genuinely can expect that when you rebuild a binary, it'll be the same. And it's a nice two-way link out to my build in Jenkins, which I can see succeeded after I ran it in each step. And again, the whole thing took, with absolutely zero caching, it looks like the whole thing took about, call it 19, 20, 24 seconds, which is very nice. Now, granted, very, very trivial application, but still. And from there, then the last part of that repository of that Jenkins file is the distribution piece, putting it out on bin tray. As I said, building something is only half the battle. You have to get it to your endpoint. And there's a lot of details to be discussed, which potentially bin tray doesn't solve, about deciding how you want the device to update itself. But unfortunately, this is only a 45-minute talk, and I could spend an entire talk on deciding when to do updates. But the basic concept of bin tray and why bin tray is nice is that after you've spent your time in Artifactory doing your life cycle, you do want to get it out to devices. Devices can be globally distributed. You don't want your customers to have to wait and rely on a single server, a single FTP server that you've put up somewhere, in a data center. And you would also like it if your distribution mechanism has basic properties like being able to be run by APIs so that you can fully script whatever you want to do with it. Be able, of course, to have fully private, password-protected content. And you really want to see statistics on what you get. And so if I hop out to bin tray, I can actually see a couple of things that were pre-set up in this one. Oh, thank you. So this is what we call a product in bin tray. This is just my little demo. It has 3 builds since I started distributing it to bin tray. And it has the one package app. I can see my versions. And I can even download it here from the UI. And there it is. Now, if I go to the same site from an incognito window, oh, right, it's private. I can't see it. I meant to show something. I meant to show a different feature, but this makes one point. If I go to the same site from an incognito window, I can't get there. And if I tried to download it, you don't have to go through the UI. If I tried to download it through the API, I would also have been told you can't have that. But the feature I had meant to show you just a little bit of fun. It's probably not something that you typically do for device updates, but for other things you might, is I can actually force somebody to sign a EULA before they download my product. And I can take a record of who signed it and store that signature so that after they sign the EULA, they can download via the API. No need to go back to a UI, but I can give them this link in order to do it. And then it downloads. So there we have it. From your first commits all the way out to distribution. Fairly simple use case, but hopefully I've shown you something interesting. And I was asked to remind people that in addition to having something hopefully that you found interesting for your own work, JFrog itself is also hiring. If you found this cool and interesting and you want to get in on it, we have openings in pretty much anything you want, and there is somebody at our booth who would love to talk to you. Shameless plug there. I have fun working at JFrog. You can too. But with that, I'd really love to throw it open for any questions anybody might have. Yes? Yes. So the question is, does this work on Linux platforms? So I ran it natively on my Mac just to reduce the number of holes. Yes, I called it a .exe, but in fact, I built it on Linux. It's called a .exe because I wanted to give it an extension. Yes, this particular application was actually built. I meant to switch it over to build on Windows. That was the bug that ended up taking all of my time last night, and I eventually gave up. Not because it was that challenging to do per se, but because I was suffering with my Windows server. So yes. Mm-hmm. Absolutely. So Bintray itself runs on a pull-based model. But there's also architectures with Artifactory that push out to clouds if you're doing major cloud deployments. There's a number of different options, basically, that exist for that sort of thing. But yeah, lots of people use it that way. I think I do, but I'm a little bit reluctant to talk about that use case. Unfortunately, I'm not really at liberty to talk about everything the customers are doing. For the most part, Conan is still fairly new, and a lot of this device stuff is still fairly new. So there's not a lot of use cases out there. Just being totally honest on where it is, Conan has not actually gone 1.0 yet. It's almost there, but not quite. It's pretty flexible, and it can do pretty much anything you need from that perspective. Yes?
So I'm just having a little bit of a hard time wrapping my mind around the compatibility matrix. There's a compatibility matrix at the build perspective, and you
Yes.
built your exe, and it's compatible with all the pieces that it cares about, and that was configured in a file.
Mm-hmm.
But then what about if you've got multiple binaries on your product, and then you want to know about compatibility between those? Is there anything around this that's about that?
So at the build level, we sort the compatibility matrix. We do not yet have anything built in to handle compatibility matrices of final executables, unless you're in turn using Conan to manage those. It's a slightly different problem set. The build versus the release compatibility matrix problem set is slightly different. You could probably use Conan that way, but I don't know of anybody who has done it yet. But one of the cool things about Conan being based on Python is that you can extend that sort of functionality fairly easily. I gave the absolute simplest use case where you just had a simple text file that described the package, but there's also Python scripts that can describe packages and tell Conan what to do with the package. Which is generally, there's a fairly simple template for a fairly simple, just wrap it up into a Conan file, but you can go more complex on those Python scripts.
Yes. Gradle invests a lot in native builds. Do you
So Gradle is an alternative package manager, and they do have some good investments. I have nothing bad to say about them. This is just an alternative.
Why not an integration with Conan and
You probably could. As to why not, I think that's more a matter of it just hasn't happened yet. Conan is a relatively new player, and I don't think Gradle has expressed a lot of interest in it yet, but it could happen. Other questions? Yes?
What's the support in our factory for Conan in the open source versus the other versions?
So at the moment, Conan isn't available in the open source edition of Artifactory. Conan has another repository that it makes available that's fully open source. But for some technical reasons, it was a little bit challenging to put it into the open source version of Artifactory. So at the moment, it is available only in the paid editions of Artifactory. My understanding is that that may change in the future, but exactly what that looks like is something I can't really speculate on. But yeah, there is a reference Conan repository available that's fully open source, but it's not the one that's in Artifactory. Any other questions? Yes?
As far as when you were showing doing the Conan install to resolve your dependencies,
Mm-hmm.
perform your build, is there a way of having that be integrated with the build system itself, such as CMake, so that when you're performing the generation of your projects, it fetches the dependencies at that time, or even at build time? Or is it typical to have it?
It's typical to do it outside. Mostly, honestly, so the question is, can you do the Conan install as part of your CMake? And the general reason why it's typical to do it outside is to reduce the footprint on your make infrastructure. One of the things that they wanted to do when they developed Conan was have it be relatively easy to migrate existing code to use Conan. And that means basically what is the least amount of change I have to make to existing make infrastructure to start leveraging what Conan can do. And kind of in that general philosophy, they kept Conan outside of the make infrastructure. Almost all make infrastructures, of course, have the ability to execute arbitrary commands at arbitrary times. So of course you could put it in. But certainly the way it's designed right now, its intent is that it will be outside as a pre-build step. It works a little bit better than some of the things that my dad used to tell me, where he would say, well, the first thing you do with make is you run about half a dozen awk scripts on your make to set it up for your environment. So it's a little bit simpler than that, but it is kind of, there's still sort of that sort of infrastructure that you're talking about in some ways. Any other questions, comments? I will be at the booth all afternoon. If you want to stop by, if you have not already stopped by the JFrog booth, I strongly recommend that you do so. Cool T-shirts, a raffle for an Echo at the end of the day. Lots of nice, cool stuff. So if you haven't dropped by all means do so. And thank you very much for your attention.